Hello. So we are going to start our exercise in Erlang. This is the Erlang shell. We have Erlang ODB version 26 installed on our MacBook, and as you can see, once we're inside the shell, we can play around with various features of Erlang. To begin with, we're going to start with primitives. Now, the thing about Erlang is that it's a functional programming language, which means that once you assigned a value to a variable, it stays. You can't really change it. It's a constant by default. Now, coming from other languages, you might find this troublesome, but I assure you, once you get the hang of it, you will harken back to your days as a mathematician and see how much sense it really makes. Because if x is equal to x, then it can't be equal to x plus 1. Why should it? It does make sense logically, right? Well, if you don't get it now, you will get it eventually. So we start off with variables. Variables in Erlang are defined with a capital letter. So x equals 1. And Erlang, once we put it into the shell, dutifully acknowledges that yes, indeed, x is 1, and it has no problem with it, and no errors are thrown. We can have another variable, y equals to 2, and it also acknowledges the fact that yes, y is equal to 2, got it, 2. If you notice that every statement if you're writing ends with a full stop, a period, because sentences is what we're doing. We're talking to the computer in sentences like a human should, and the computer should respond back in a similar way. Now, what kind of numbers? Well, you've got the usual decimal systems. Yes, you've got, if you ask what is x, it will respond with telling you that it is 1, that's a decimal number. But you could also say, for example, y, which is 2. But you know that in binary it's different. So because if you say there are two kinds of people, those who know binary and those who don't. So there are actually 10 kinds of people, 1-0 kind of people who know binary. Those who know binary, those who don't. So yeah, is this true? 2 in binary? Yes. So this is how you write binary numbers. You write with a 2. And so that makes sense that if you were to write a number like 8 hash 10, that would be an octal. And similarly, this is hexadecimal. That's actually 16. What do you know? Right. So yeah, so this is how you write numbers. If you don't specify anything before the hash and you don't specify the hash, then understand you're talking about a decimal number. But if you put 2 hash, 8 hash, 16 hash, well, it's the base. Now, we have assigned these variables. We could create another variable, we could create another variable like a point, which is equal to x and y. But okay, we will talk about that later. Before we get there, the usual comparison operators apply. So yes, is x greater than y? False, because yes, x was 1, y is 2. Okay, is y less than, greater than or equal to x? Then that is true, because it is 2 is greater than 1. So you could do that. We could also do comprehension. We could also do comparisons like this. For example, we could compare. Are they the exact same number? And that's true. This is how you do an exact same number. You could also do that. Yes, a binary 10 is a decimal 2. Yes, we know that. Okay. What's the difference between this and this? This is more precise. So if you were to say this is 2.0, then I would disagree with you because, you know, we haven't specified the floating point. Yep, that is how we are going to be very precise in what is called pattern matching. So Erlang's all about matching patterns. If it sees patterns like a beautiful mind, then everything's great, everything's fine, and it will not disagree with you. The computer will be your friend and not kill you. But if you didn't specify the pattern matching, then you got to deal with problems. Then you got to do some issues. So what are these comparisons? Well, you got to, what is it like? Well, it says the numbers are less than in value to, for example, atoms. And what are atoms? Okay, that's something new. In Erlang, we have something called atoms. Now, we've talked about numbers, we've talked about variables. What are atoms? Atoms is just words. Just words. It could be a simple word like, I don't know, the word atom itself is an atom. It's atomic. There's no value assigned to it. It is what it is. It's not a string. It's a label. Let's think of it as a label, right? So, for example, if we say that this is the number 1, it should be, is it greater than the atom? Well, it's not. So yeah, actually 1 is less than an atom. That's true. Number. And what about 2? 2 is also less than an atom. That's brilliant. What if we had an atom called 2? Now this is going to play crazy. We've got an atom called 2. We've got an atom called 1. Is 1 less than 2? It's true. Is 2 less than 1? No. What is 2? Is it the number 2? No, it's just an atom. That's what it is. Why is that? Why is 1 less than 2, but 2 is not less than 1? Because in this case, we are comparing the atoms to each other, and that is just a referential. So, without going into the details of what atoms are doing, we could choose a number 2, and that's a variable, because this is, of course, has a capital letter. So if you do that, it tells you that actually 2 is 2. And we could also say that 1 is 1, and that's fine too. Atoms. We will come back to them when we are talking more about data structures. Back to our original. Remember, we had defined x, we had defined y. What we couldn't do is say x equals x plus 1, because if you do that, you got a problem. This is what I was talking about, that an x is a constant. You can't change it. It's what's called referential transparency in Erlang. But what you can do with x and y? Well, you could create a new variable called point, which is equal to x and y in a tuple, and that's fine. And that's fine. You could create a variable called x2, which could equal x plus 1. That's fine too. You could create a point 2, which could be equal to x2 and y. So now you've got another point. What happened there? Oh, okay. That should be fine. We've got a point 2, point 1, and point 2. Oh, it's just called point. It was just called point. And you had point 2, which was that. So this is how you can manipulate data. But what you cannot do is this stuff, x equals x plus 1. Definitely not allowed. Other primitives include lists. Lists are amazing things. Lists are just fantastic. So what we can do with lists is, let's create one. A list is a collection. It's a collection which is bound by square brackets. Could have point, could have point 2, it could have an atom in it, it can have a floating point number in it. So they've got a list, and remember, that's what it looks like. You can also find out what the way the list is constructed is that there's a first element of the list, which is the head. So you could actually say head of list, and it will tell you that the first element is that, and the tail of list would be the rest of it, essentially. And you could chop its head off if you wanted to. So you could add, for instance, to a list by saying, so list plus something else. We're going to put another list, and this time it's going to be a 1, a 2 to it, and we have the list has been increased. We can do list and subtract something from it, like 1 and 2, and you could have this. And remember, you can see that this, in this instance, we only did it once, the operation. It did not change the value of the list. It would just performed an operation on the list, adding the atoms 1 and 2, and in this case subtracting the integers 1 and 2. But if we go back and ask what the list is, the list, of course, is unchanged. It's what we defined it as. You can also make lists with other lists. So you could make a list called, I don't know, evens, which is going to have numbers, a list of numbers, which are such that the number is such that it's coming from another list, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's coming from the list, and the number when you divide it by 2, the remainder is equal to, there's no remainder, basically, there's 0. So that's a new list, a very long definition, but it should give us 2, 4, 6, 8, all the numbers that are even in that. So you can create a new list. So you can have evens. Yes, it's there. And so you could create a new list called jumble, which is a list plus evens. And yes, now you've got jumble, which is the, all sorts of weird things in it. So yeah, you could do that with lists. Next, we come to bit syntax. Bit syntax is a really fun bit. So I'm going to just create another video for it, and this is the end of this one. And we'll talk about bit syntax in the next video.